Hey guys, so for today's lesson, we're going to be going over the difference between compounds, molecules, as well as ions. So we're going to start talking about how different compounds and molecules are bonded to one another and how they form. Okay, so this lesson is titled Molecules and Compounds. And what we're going to be looking at is what the difference is between molecular elements, molecular compounds, and ionic compounds. You also need to know the difference between cations and anions and how they form. And then we're briefly going to talk about how the atomic ratios in compounds and molecules affect the properties of those compounds and molecules. So the chemical formula is just what we use to show the number of atoms in a pure substance, as well as the types of atoms in that pure substance. So the letters represent the elements, the subscript numbers indicate the number of atoms of each of those elements. If there is no number after an element's symbol, that means there's only one of them. So for example, H2O means that there's 2 hydrogens and 1 oxygen atom in a molecule of water. Molecules are atoms that are chemically joined together. They can be made up of 2 or more atoms. They can also be made of just one type of element or different types of elements. And you can see in this image at the bottom here, at the top, we have just single atoms. Underneath in the next 2 rows are all different types of molecules. Molecular elements are any molecules that only contain one type of element. And the most common type of molecular element is something called diatomic molecules. Diatomic molecules are molecules that have 2 atoms of the same element. The 7 most common diatomic molecules are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And you do need to memorize those. So you have to know, when we talk about the diatomic molecules, those are the molecules that we're talking about. They're often, or sometimes, also referred to as Hofbrinkel molecules. You can write out the letters to spell Hofbrinkel. It's also important to note that these diatomic molecules never show up just by themselves as a lone element. So if I say we have some nitrogen gas, that isn't just a single N. Nitrogen gas is always N2. Same with chlorine gas or oxygen gas or bromine or iodine. They always show up in that diatomic form unless they're bonded to another element. Molecular compounds then are molecules that contain more than just one type of atom, so more than just one element. Most molecules will fit into this category. Sometimes they might only be made of 2 atoms and 2 elements, like carbon monoxide is just a carbon and an oxygen, or sometimes they are thousands of different atoms, like protein molecules. And you can have molecules that are formed with the exact same elements, but with different ratios of them. So for example, alcohol and vinegar are both made of carbon, hydrogen, and oxygen, but the ratio of carbon to hydrogen to oxygen is different. Same with like H2O compared to H2O2. The only difference between them is one has 1 more oxygen than the other. One is water, one is hydrogen peroxide. Only certain combinations and ratios will occur naturally. So properties of molecular elements. Molecular elements contain, again, only one type of element, but the number of atoms of that element will drastically change the properties. So for example, O2, which is a diatomic molecular element, and O3, which is ozone, also a molecular element. Oxygen is what we breathe. Ozone is poisonous. So very different properties. Okay, ions. This is probably, other than the diatomic molecules, like one of the big things that you have to take away from this lesson. Ions are any charged particle. So if a if an atom has either lost or gained electrons, it becomes an ion. Electrons have a negative charge, so if you lose that negative charge or you get more of that negative charge, you become a charged particle, so an ion. Positive ions are called cations. They are formed anytime an atom loses electrons. Negative ions are called anions. They are formed anytime an atom gains electrons. When we are writing the chemical symbol for an ion, you do have to show its charge. Charges are also always written as superscript, so they're written like up top beside the letters that denote the chemical. So for example, chlorine, a chlorine ion would look like this, Cl-1. A calcium ion would look like this, Ca+2. And you are going to have to memorize the charges for all of the elements with the exception of the transition metals. And we'll go over how to do that when we talk more about ionic compounds. So ionic compounds are compounds that are made of oppositely charged particles. So essentially you have a positive ion and a negative ion, or another way of saying that, a cation and an anion, that because they have opposite charges are attracted to each other. And we'll get more into this in the next lesson. This is kind of what they end up looking like there at the bottom. Okay, so a summary of these different types of compounds. You've got molecules, which are just anytime you have two or more atoms joined. Those could be molecular elements, which are made of only one type of element. Those could be our diatomic molecules or our Hofbrinkel, or they could be things like ozone, which have more than just two of that element. And then there's also molecular compounds, which can either be the ionic compounds, which are made with our charged particles, our ions, or our non-ionic compounds, sometimes just called molecular compounds for short, to kind of separate them from the ionic compounds. Okay, and that is it for today's lesson. Don't worry about that. We'll take up kind of talking more about how different compounds form in the next lesson.